Welcome back to learn intermediate JavaScript on Codecademy. We're in the modules section. This is implementing modules in Node. This is an article on modular programs and implementing modules in the Node runtime environment. So it is recommended you have a text editor and Node.js installed so that you guys can go over some of the examples that we'll be looking at. What are modules? Modules are reusable pieces of code in a file that can be exported and then imported for use in another file. A modular program is one whose components can be separated, used individually, and recombined to create a complex system. Consider the diagram below of an imaginary program written in a file, myapp.js. Myapp.js is able to import from all these other modules. Note the words module and file are often used interchangeably. Instead of having the entire program written within myapp.js, its components are broken up into separate modules that each handle a particular task. For example, the database logic module may contain code for storing and retrieving data from a database. Meanwhile, the date formatting.js module may contain functions designed to easily convert date values from one format to another, a common headache among programmers. This modular strategy is sometimes called separation of concerns, and it's useful for several reasons. What do you think those reasons might be? Write down a few of your ideas before revealing the reasons below. Let's check those out. By isolating code into separate files called modules, you can find, fix, debug code more easily, reuse, recycle, define logic in different parts of your application, keeps information private and protected from other modules, prevent pollution of the global namespace and potential naming collisions by cautiously selecting variables and behavior we load into a program. Implementing modules in your program requires a small bit of management. In the remainder of this article, we will be covering how to use the Node.js module exports object to export code from a file, meaning its functions and or data can be used by other file or modules. How to use the Node.js require function to import functions and or data from another module. Implementations of modules in JavaScript, Node.js versus ES6. Before we dive in, it should be noted that there are multiple ways of implementing modules depending on the runtime environment in which your code is executed. In JavaScript, there are two runtime environments and each has a preferred module implementation. We have one, the Node runtime environment, and the module exports and requires syntax. And then there's the browser's runtime environment and the ES6 import-export syntax. So one environment, Node, we use module exports and require syntax, while when we use import-export in the browser's runtime, we do use the ES6 import-export syntax. This article will focus on using the module exports and require syntax in the Node runtime environment. For more information, you can read the two articles linked below. There's implementing modules using ES6 syntax and introduction to JavaScript runtime environments. And the runtime environment is just where our program will be executed. Implementing modules in Node. Every JavaScript file that runs in a Node environment is treated as a distinct module. The functions and data defined within each module can be used by any other module as long as those resources are properly exported and imported. Suppose you want to write a simple program that would display the freezing point and boiling point of water in Fahrenheit. However, you only know the values in Celsius to be 0, freezing, and 100, boiling. Luckily, you happen to know how to convert Celsius to Fahrenheit. Such a program might look like this. So this is called waterlimits.js. We could copy this and see what it does. Let's go over here. I'm going to open my text editor, add a new folder, make a new file. Okay, paste it. Save it, go into our new folder. We see our waterlimits.js file that we just created. We're able to run our Node file. When we run it, we get the freezing point of water in Fahrenheit is 32. The boiling point of water in Fahrenheit is 212. And if we look at this, we know that that's able to happen because we have first our function here, Celsius to Fahrenheit, which takes in Celsius, and then we'll multiply Celsius by 9 divided by 5 plus 32. We have const freezing point C is assigned 0 and const boiling point C is assigned 100. we have const freezing point F is assigned Celsius to Fahrenheit with freezing point C passed in, while const boiling point F is assigned Celsius to Fahrenheit with boiling point C passed in. And then down here, when we log, the freezing point of water in Fahrenheit is, we use interpolation to pass in the value of freezing point F, as well as here, the boiling point of water in Fahrenheit is boiling point F. When we run our program, we do see 32 and 212. Let's go back and continue the article. So we did this, we copied that, and we seen what the result was. This waterlimits.js program is simple, but let's break it down into its parts. At the top of the file, the function Celsius to Fahrenheit is declared. When given a value in Celsius, it will return the value converted to Fahrenheit. Both input and output will be a number. Below freezing point C and boiling point C are assigned the known values 0 and 100 respectively. Using these values in the function Celsius to Fahrenheit, the additional values freezing point F and boiling point F are calculated. Lastly, these values are printed to the console. Executing this file using Node would look something like this. Node waterlimits.js, and that did run the same code. Now you decide to write a second program. In this program, the user can input any temperature value in Celsius, and the program responds by printing the input temperature converted to Fahrenheit. For example, you might want to be able to run such a program and see a response like so. So we would run node Celsius to Fahrenheit.js, we pass in 100, and it would print out 100 degrees Celsius is equal to 212 degrees Fahrenheit. The JavaScript below would do just that. So let's copy this, and it's going to break it down. We'll get to see it. Let's read through this first, and then we can see it in action. Now let's break down the Celsius to Fahrenheit JS program. At the top of the file, the function Celsius to Fahrenheit is declared. When given a value in Celsius, it will return the value converted to Fahrenheit. Both input and output will be a number. So we take a look here. We got function Celsius to Fahrenheit. It's passed in Celsius. It's then going to return Celsius times 9 divided by 5 plus 32. When it's given the value, it's going to return the value converted to Fahrenheit. On the next line of code, Celsius input is assigned process argv2. When a program is executed in a node environment, process argv is an array holding the arguments provided. In this case, it looks like node Celsius to Fahrenheit.js and then 100. So for us to access 100, we would do process.argv with index 2 specified, which would be the third element in the array, which is the value that we pass in. So process.argv2 returns 100. Using the value in the function Celsius to Fahrenheit, the additional value's Fahrenheit value is calculated. Lastly, a message is printed to the console displaying this data. Notice anything similar between the two programs, waterlimits.js and Celsius to Fahrenheit.js? Both programs implement the function Celsius to Fahrenheit. Not only did we write this function twice, but if we ever need to make changes to the function, we'll also have to make changes in two places. Creating a module that exports a Celsius to Fahrenheit function that can be used by both of these programs would solve this repetitive code program. So let's see what that looks like over here. So now let's see what they called it. It was Celsius to Fahrenheit. So first let's create this file, and we'll do that here. We got that file. Let's go over here, and we're going to copy that. Go here, save it, let's run it. Pass in a number like 105, run it. 105 degrees Celsius is equal to 221 degrees Fahrenheit. And so what they're telling us is both these files here have access to the same function. So if we ever want to make changes to this function, we would have to go to both of these files to update it. So with using modules, we would be able to import Celsius to Fahrenheit from another file and use it in any of our files. And we would only have to make changes in one place if we ever update it. And it's going to update it everywhere else that it's imported. So let's continue on. Module exports. To create a module, you simply have to create a new file where the function can be declared. Then, to make these functions available to other files, added them as properties to the built-in module exports object. Here we have a file, converters.js, and it has that Celsius to Fahrenheit function. We then do module.exports.Celsius to Fahrenheit and assign it Celsius to Fahrenheit. We have module.exports Fahrenheit to Celsius is assigned this anonymous function that takes in Fahrenheit and will return Fahrenheit minus 32 times 5 divided by 9. The code snippet above demonstrates two ways of exporting functions from a module. Let's break it down. Let me copy this. Well, first let's create a converters.js file over here. New file. We have that. Let's grab this code. Go back over here. Save it. So now we have our Celsius to Fahrenheit function, and we export it, which will allow us to pull it inside of our water limit and our Celsius to Fahrenheit file without having to have that function take up space in the files. So let's go back and keep reading. The code snippet above demonstrates two ways of exporting functions from a module. Let's break it down. At the top of the new file, converters.js, the function Celsius to Fahrenheit is declared. On the next line of code, the first approach for exporting a function from a module is shown. In this case, the already defined function Celsius to Fahrenheit is assigned to module exports Celsius to Fahrenheit. Below, an alternative approach for exporting a function from a module is shown. In this second case, a new function expression is declared and assigned to module exports Fahrenheit to Celsius. This new method is designed to convert Fahrenheit values back to Celsius. Both approaches successfully store a function within the module exports object. Module exports is an object that is built into the Node.js runtime environment. Other files can now import this object and make use of these two functions with another feature that is built into the Node.js runtime environment, the require function. Require. The require function accepts a string as an argument. This string provides the file path to the modules you would like to import. Let's update waterlimit.js such that it uses require to import the Celsius to Fahrenheit method from the module export object within converter.js. So if I copy this, let's paste it in Atom, water limits. So now we see here const converters, it requires the converters.js file. We then have const freezing point C 0, const boiling point C is 100. We then do const freezing point F is assigned converters.Celsius to Fahrenheit with freezing point C passed in, and then we have const boiling point F is assigned converters.Celsius to Fahrenheit with boiling point C passed in. We then are able to log the freezing point of water in Fahrenheit is with freezing point F passed in, and then we're able to log the boiling point of water in Fahrenheit is boiling point F passed in. Let's run this and see what happens. So when we run it, we are able to access our Celsius to Fahrenheit function, and we can see the results here. Let's continue on that article. So in this case, ./ is a relative path indicating that converters.js is stored in the same folder as waterlimits.js. When you see require, the entire module exports object is returned and stored in the variable converters. This means that both the Celsius to Fahrenheit and Fahrenheit to Celsius methods can be used in the program. So using object destructuring to be more selective with require. In many cases, modules will export a large number of functions, but only one or two of them are needed. You can use object destructuring to extract only the needed functions. Let's update Celsius to Fahrenheit.js to only extract the Celsius to Fahrenheit method, leaving Fahrenheit to Celsius behind. So let's copy this and go into Celsius to Fahrenheit. Paste it here. So here we're using destructuring to only bring in Celsius to Fahrenheit from converters.js. We then have const Celsius input is assigned whatever's passed into argv2. We have Fahrenheit value is assigned Celsius to Fahrenheit with Celsius input passed in. So here we are using our Celsius to Fahrenheit function that we are grabbing from our converters.js file. Let's save it. Let's test it out. Node Celsius to Fahrenheit with 125. And we do get 125 degrees Celsius is equal to 257 degrees Fahrenheit, so it is working. Let's go back. With this approach, the remainder of the program works the same way, but the program avoids importing a function it does not need. Our code challenge says complete the shape area module. Your module must declare and export two functions with the following signatures. It should have circle area with radius length passed in and square area with side length passed in. You may create these as either named functions or anonymous function expressions. Okay, so let's do that now. Let's run it. Let's check answer. So we do pass, which is telling us that our shape area.js has successfully exported circle area and square area. Let us continue. Code challenge, complete the program app.js. First, import the shape area.js module using the require function. Shape area.js is in the same folder as app.js. Choose one of the two options below for storing the returned module exports object. A. Store the entire module exports object in the variable area functions. Or B. Use object destructuring to extract the circle area and square area methods into their own variables, circle area and square area. Next, call the circle area function with the provided variable radius as an input. Assign the return value to the variable area of circle. Then call the square area function with the provided variable side length as an input. Assign the return value to the variable area of square. You may print the values of area of circle and area of square to the console to see your code work. Here we have app.js. We see it has this const radius of 5, const side length of 10. So we have option 1, import the entire shape area JS module here, or option 2, import circle area and square area with object destructuring. And it looks like they've actually already did option 2 for us. We have const circle area and square area should be created as variables and grabbed from the shape area.js file. So use the imported circle area and square area methods here. So we do have area of circle, and we can replace this with circle area and radius passed in. And we could do the same with area of square. So we should be able to run this. It does say to log it to see if we get the right responses. Let's do that now. Let's run it. We do get our area of circle as well as area of square. Let's check answer. And we do pass. So review. In this article you learn the following: the benefits of implementing modular programs, how to use the Node.js module exports object and to export code from a file, meaning its functions and or data can be used by other files or modules, how to use the Node.js require function to import the functions and or data from another module, how to use object destructuring to only import the desired components of a module. Congratulations on reaching this milestone. With a little more practice, you'll soon be able to handle Node.js modules with ease. Make sure to practice this and go over it. The more you do it, the easier it is to remember every time. Make sure to practice it, and I'll see you in the next video.